Here we have a demonstration called viscosity tube. We know different liquids have different properties, and one of the properties is a viscosity. Viscosity is nothing but the resistance to flow. Water, milk, fruit juice, they have almost comparable viscosity. They are reasonably thin and they can flow easily. But there are some liquids which are thicker. One can say they are viscous or more viscous, such as honey or corn soup or shampoo or liquid soaps. They are more viscous, and you can see the practical implication of that. The honey flows very it's very difficult. It doesn't flow that easily, but water can flow easily. The viscosity and fluidity, they are exactly opposite, or they are inverse. If viscosity is more, fluidity is less. If viscosity is more, fluidity is less. And if fluidity is more, viscosity is also more. So, and it has a practical application, as I told. When you have certain cream or shampoo or some ointment in a tube, or your toothpaste, if you try to squeeze it, sometimes it very easily comes out. Sometimes you have to press very hard, and you have to apply more force because viscosity is more. But sometimes it comes very easily. If you tune the property viscosity, then one can decide the quality or property of the product. You can tune the property by tuning the viscosity of that liquid. And one can say kitchen also, at different times we use different liquids which have different viscosities, like our cooking oil or kerosene or sugar solution. They have different viscosities. Honey has a different viscosity. So one can see the viscosity has a very practical utilities in our day-to-day life. Now let's move to the demonstration. Here I have 3 cylinders. They are transparent cylinders, and we have filled different liquids in these cylinders, and they are sealed from both the sides. One can move it or rotate it along a horizontal axis. The viscosity of this first tube, liquid in the first tube, is more. The viscosity of this extreme or the opposite tube is less than that, and the viscosity of the central tube is the least. So you can see there are 3 balls in these tubes. In each tube there is one ball. Volume and mass of these balls are same. They are equal in all respect, only their colors are different. Now if I invert these tubes, you just see what happens. The central ball in the central tube goes first because its viscosity is least. Then comes this tube. Then comes this third tube, because viscosity is most or highest in this tube and viscosity is least in this middle tube. So one can practically see how viscosity, or rather one can say it is like a speed breaker. It controls the speed of the object which is moving in that liquid. So more the viscosity, more the resistance. Viscosity is nothing but it is the resistive force of the liquid. So one can see and experience the viscosity and enjoy the model. Thank you very much.